What will it take to transform our throwaway economy into one where waste is eliminated, resources are circulated, and nature is regenerated? The way we choose, consume, produce, and waste food is one of the greatest threats to our planet. As much as 1/3 of all food produced is either lost or wasted before it reaches consumers' plates. Most of this waste isn't recycled, but instead takes up more than 20% of America's landfill volume. Food waste has deleterious effects on the environment, our society, and the financial system. The main cause is the adoption of a linear economy system based on a take, make, consume, and dispose pattern, where the connection between resource use and waste residuals is not being adopted. We must transition from our linear take, make, consume, dispose economy to a circular one in which we use something and then find a new purpose for it. This process is critical to protecting our planet from the constant depletion of natural resources and the threat of greenhouse gases. In the circular economy concept, the value of resources is maintained in the system as long as possible, and products are reclaimed to extract as much value as possible before safely returning them to the biosphere. Waste represents not only an economic loss, but a significant waste of freshwater resources used to produce food, and a misuse of what could otherwise feed millions of low-income people who struggle with food security. There's a better end for food waste than taking up space in landfills and contributing to global warming. We need to explore and develop new processes and technologies for nutrient reuse. And this is one of the main challenges in waste management within a circular economy. Food waste is rich in energy, water, and nutrients, all of which are very valuable, useful resources. We tap these resources and return them to the soil for the benefit of agriculture. We can recycle them into high-value agricultural products. By adopting biotechnological processes that allow nutrient recycling and the implementation of climate-smart agricultural approaches, more sustainable agriculture and food systems can be achieved. For example, pyrolysis of ag waste such as almond shells can be used to produce biochar and wood vinegar. Wood vinegar has been used for ages as a sterilizing agent, fertilizer, and antimicrobial. Biochar is used as soil ameliorant for both carbon sequestration and soil health benefits. In another example, microorganisms can be used to carry out anaerobic processes to ferment organic waste into many useful biowastes. At UCR, we take locally available waste, such as citrus fruits, to transform them into soil nutrients, liquid fertilizers, and insect feeds. At the same time, we are leveraging natural processes and elucidating the positive role the rich biowaste amendments have in altering the natural plants and soil microbiota. By affecting native microbes and their functions, the recycled food waste harnesses the innate capacity of the soil and root system to convert nutrients to plant food, protect plants from pathogens and stress, and enhance plant growth and resilience. Most importantly, we can bring positive changes and benefits out in the real world of farming. Nevertheless, those biowastes have many different uses. First, the black soldier fly larvae can be fed directly to chickens or fish in aquaponic systems. The larval biomass can be defeated and transformed into high-content protein flour that will then be the main ingredient of fish meal, making this much more sustainable than it currently is, and food for dogs and cats. The fat can be used as biofuel. Chitin can be extracted from pupal exuviae and adult bodies and used as nematicide, or to extract chitosan, which in turn has few applications itself. The frass, that is, the digested biowaste, can be used as fertilizer or for soil amendment. Waste management can help achieve the global development goals, but we need to come together. Forging interdisciplinary research collaborations and building public-private sector partnerships will help solve the challenges facing the global ag-food system. Together we can improve lives with science, bringing innovation through collaboration, for the betterment of the health and well-being of humanity and the planet. A special thanks to the University of California Global Food Initiative for supporting our Circular Economy Initiative. The initiative aligns the university's research, outreach, and operations in a sustained effort to develop, demonstrate, and export solutions throughout California, the United States, and the world for food security, health, and sustainability.